Hey class, here in Module 4, Lesson 4, we are going to relate sidelinks to the arrays that we've been doing into area for finding area. So I did a little bit of this in the last video, and we did a little bit of it in class as well in Lesson 3, showing you that you can look at a grid, and if it has 2 on one side and 4 on the other side, you can look at that as an array, a 2x4 array, and um, multiply, right, to find the area. And so we can definitely, as you're going to see, we can definitely take a rectangle and draw in the grid to show those squares, but we're going to even move beyond that to the point where we don't need to draw that in. Oh, my cord's in the way here. We don't need to draw that in, and we can skip that step eventually and go right to multiplication. So first things first, let me show you how to actually draw the grid in, and then I'll show you how to get rid of it and just multiply and make your life easier, save you time. All right, here we go. I have the problem set here, which you've already done at this point, but it's always good to go over these after the fact, and then you can sort of better understand what it was we did today. So it says use a ruler to measure the side lengths in centimeters, and then we're going to draw on the grid basically. So I have my ruler here, and I'm going to see that that's 2 centimeters. So I'm going to put a mark at 1 centimeter on this end, and a mark at 1 centimeter on this end, and use a straight edge, in this case a ruler, to connect those. Okay, then I'm going to do the same on the top and the bottom. So I have, let's see. All right, we have 1, 2, 3, 4, 5, 6, about 7. It's hard, like they draw these one way, and then, or they make them one way, and then as soon as you copy them, right, on a copier, the size gets a little off, and that sort of defeats the purpose a little bit of being exact. But there's not much we can do about it. So now I'm going to connect the tops and the bottoms. And when you're done, or when I'm done, you're going to see that this looks just like something that would have come pre-printed for you. And you'll see that other than this last one that got a little too short because of copier, we have 1, 2, 3, 4, 5, 6, 7 rows, or 7 columns and 2 rows. So I would label this as a 2 by 7 grid or array. And the total area, again, I could go, count 7, 14 is 14 square centimeters. Again, that unit being very important, 14 square centimeters. I prefer to multiply, and that's what you're eventually going to be doing too. So I would say 2 times 7. So 2 times 7 equals 14 square centimeters, right? And so if I knew that this was 2 and this was 7, right, I could multiply without ever drawing these in. So that would have saved me some time and effort and energy. You just measure, say that's 2 centimeters, that's 7 centimeters. I can multiply them. That's where we're headed with this. I always like you guys to know the direction we're going. So it's important that we learn how to do this work, but I also want you to know the direction that we're eventually headed so you can understand what it is we're working toward. So here we go. We'll do it again on this side. 1, 2, 3, 4, 5, 6, and again 7. And then you always have to do it on both sides so you can line them up. If you just draw it on like one side and then try to line it up, your lines never end up straight. And then your squares don't come out as squares, and then we've defeated the purpose of the exercise. And along the top, I have 5. So 1, 2, 3, 4. So you can see that this is going to work, right? But it's going to take me time. Like this takes time and effort and some precision to get right. Sorry, I know that like the view of the actual me and not my my paper here is probably just like me super close up to the screen, but I need to be able to see where I'm drawing. Okay, so I've drawn my lines horizontally, and now I need to draw them vertically. So when I'm all done, I've made this nice grid with 7 centimeters on one side, 5 centimeters on the other side. So when you find area, you multiply like length or width times height. So you multiply one side by the other side. Obviously, a rectangle has 4 sides, but you only multiply, two uh, adjacent sides to each other. Adjacent means next to, so 2 sides that are next to. So 7 centimeters by 5 centimeters. This is also 7 centimeters, and this is also 5 centimeters, right? Opposite sides are equal in a rectangle. So 5 centimeters on top means 5 centimeters on bottom. 7 centimeters on the left, this means 7 centimeters must be on the right. But when you're finding area, you just multiply 2 of the sides together. So I would say 5 centimeters times 7 centimeters equals 35 square centimeters. Right. Now, you could go through and say 5, 10, 15, 20, 25, 30, 35. That works too. But I'm showing you that we're going to eventually get to the point where we multiply the side lengths in order to find area. All right, let's look down at the one on the bottom. And I wish this thing had a better zoom feature so you could see the text a little better. But Mariana uses square centimeter tiles to find the side lengths of the rectangle below. Label each side length, then count the tiles to find the total area. So when you're given this side length, or you're given the grid inside the rectangle, you can just say, well, that's 1 centimeter there. That's another one, and that's another one. There's 3 centimeters, or 3 rows, 3 centimeters represented by 3 rows. Sorry, I lost my train of thought there for a moment. And then you'll see that each row, it has 4 centimeters in it. So I have 3 centimeter by 4 centimeter grid. So 3 centimeters times 4 centimeters equals 12 square centimeters, right? To get real technical with you here, the reason they're square centimeters is because you're multiplying centimeter times centimeter. Anytime you multiply a centimeter times centimeter, it comes out to something called square centimeters. So and you end up with 12 of them in this case because you have 3 rows and 4 in each row. All right, let's take a look at the back. Each square is 1 square centimeter. Saffron says that each side length of the rectangle below is 4 centimeters. Kevin says the side length is 5 centimeters. Who is correct? Explain how you know. This is another one of those classic problems we get in 3rd grade where it's like this guy says one thing, this girl says another thing, and who's right? And often the answer is both, and it is in this case because it depends on where you're looking. So if you look here on the left or all the way on the right, it is 4 centimeters, right? The side length from there down to there is 4 centimeters. But if you look at the top and go from the left to the right, it's 5 centimeters. So essentially they are both correct. 2 sides are 4 centimeters and 2 sides are 5 centimeters. If you want to get real advanced on me here, you could say the total area is 20 square centimeters because 4 times 5 is 20. All right. The next part says use both square centimeter and square inch tiles to find the area of the rectangle below, which works best and why. So we'll put our trusty tools here, and I think we'll start with square inches. I have 1. This is real simple, right? They fit right in there. So it's either 3 square inches. Right, that one was straightforward. And since this is asking me like which works best and why, I'm assuming that it's about to get less efficient here. Otherwise, they wouldn't ask that question. 1, 2. Now you'll notice here. I'll do it. I'll put them line them up on the bottom. I put 2 there on the bottom, and if I put a third one in, it doesn't fit, right? So I can't actually fit the centimeter tiles in there, right? So I'm going to say, I'm not going to go any further. I'm going to say the square centimeters don't really work. They don't fit. I can't use those as easily, right? I'm going to have halves of centimeters, which is doable. Like as you get older and more advanced, you can do that. You can find area that way, but you can't use the tiles efficiently to measure that. So um, the square inches work best because you're measuring in holes. Holes as in like a whole of not parts of a whole, but the whole thing. Centimeters may make you have to work in fractions. I know we haven't covered fractions yet. That's unit 5 for us. Oh, sorry, my camera fell and you couldn't see everything on the page anyway. But fractions are parts of wholes, so we'll get into that more here in the next module. And the last question, the last sort of topic covered in this lesson is how does knowing side lengths A and B help you find side lengths C and D? So we kind of covered that in the top problem on this page, problem 4, where in a rectangle or square, opposite sides have the same side length measurements. So knowing side length A tells you side length C, and knowing B tells you D. Now that's true, but I would encourage you to go above and beyond that and say this is true because in a rectangle, opposite sides have the same measurements. Just barely squeezed it in on the page there. All right, that is it for lesson 4. Again, it's similar to lessons 2 and 3. As a warning, it's similar to lesson 5 as well, but the reason we're getting so many similar lessons on this topic is it's really important. It's important to know how to use square inches and square centimeters to measure area. So it's giving us practice identifying side lengths. As you saw today, it's giving us practice multiplying those side lengths to find area. That was a little bit of me previewing what's to come. Technically, this lesson's not supposed to cover that, but as you guys know, I like to introduce things that I like you guys to know the point. I like you to know where we're going and start using those things early on because you're capable of doing that. And it also gave us practice, again, going back and understanding the difference between different units and why it's important to identify different units and use the correct units. And again, knowing that a square inch is bigger than a square centimeter is really important, and it helps you understand how to compare areas and how to compare something, two things that have the same numeric measurement, like they might both be 5, but something with a square centimeter measurement of 5, 5 square centimeters is much different than 5 square inches. So we got some more practice with that sort of stuff here in this lesson today. All right, guys, on to lesson 5. Good luck with your homework, and please let me know if you have any questions.